and then we'll work on any problems you want. So if we are given p prime of x, the integral from 4 to 10 from p prime of x dx represents the from day 4 to day 10. What does it represent? Of course, this is a marginal profit.
The total.
Yes, total.
The total revenue.
The total.
Revenue. Oh, profit.
That's it. Indeed, the integral from day 4 to day 10, or month 4 to month 10, year 4 to year 10, it doesn't matter, is the total profit. Excellent. Now, number 2. I should have put number 2 here, not here. Sorry about that. Fundamental theorem of calculus shows how to find this integral. Can anyone give us the answer?
It shows how to find the definite integral.
Yes? Yes, this is the
And then it's
definite.
going to be f of x. And then it's going to be like a slash. And then on the bottom it's going to be ab.
Good.
And then it's equal f of b minus f of a.
Perfect. Remember that these two functions are not the same, right? This is the antiderivative of this. Antiderivative of f of x. Perfect. Given that, so this is true, given that f of x is a function. What do I write in here? Say it again.
Is it linear?
It can be any function. It can be exponential. It can be anything.
Is it
continuous?
Absolutely. This formula, or the fundamental theorem of calculus, is not applicable if this function is not continuous on AB. Please remember that. This is not applicable if this function is not continuous on AB. So let me give an example. So if I have the integral from -3 to 1, from 1 over x dx, can I use the fundamental theorem of calculus?
Is it no, because it has -3?
What is the problem in 1 over x?
It's not negative.
No. What is the
Is it
problem?
because it's ln of x?
Well, this is the n of x, but what is the problem? Before we write any of this, what is the problem here? This is not from calculus. This is from algebra. What is the problem here with this function?
X is the denominator.
Yes, that's fine. But what is the problem?
It can't equal 0.
Exactly. Do you see that 0 is here? 0 is in the interval. So we can never write this. Why? Because 1 over x is not continuous on -3 to 1. Because the function does not exist at 0. And 0 is somewhere between -3 and 1. Is this clear? This is very important. Is this clear?
Yes.
Thank you. That's why this theorem, the fundamental theorem of calculus, is applicable only if this function is continuous on AB. This function is not continuous on -3 to 1 because it does not exist at 0. Perfect. Awesome. When using substitution to evaluate definite or indefinite integrals, we have the following steps. Find the substitution. Okay. Any letter you want, depending on what the function is given in the integral. Then what do we need to determine? After I state the substitution, let's say, let u be x cubed.
We have to find our a and b as an integral.
No, after we find the substitution,
Find the differential.
yes, we have to determine du as 3x squared dx. First, thank you so much. First, we find the substitution. Step number 2 is this. And step number 3 will be what Yulia said, which is fine. Okay, now, final question here. We go back or we do not go back to the initial variable for definite or indefinite. So I'm going to use, let's say, what am I going to use? I'm going to use green and black. So for the definite integral, I'm going to use black and tell me what I need to circle. And for the indefinite, I'm going to use green, and you tell me which one I circle. For definite, we go back or we do not go back to the initial variable. For definite, black. We do or we don't go back. For definite, like this one, definite.
For the definite, we do not go back.
We
For
do not
indefinite,
go
we
back because it's a number. For definite, we do not go back. This is a number. That's why we don't need to go back. So then for the indefinite, we have to go back. We always have to go back to the indefinite, to the original variable or the initial variable. Yes. Good. Okay, so now we will continue with 24 in 4.4. Let me change this and put the page in. Where is my page? Here it is. So you said 4.4. Let me go back. If you know the page number, let me know. If not, I'll go back and find it. 4.4.
I think it's 420.
425, yes. 425. Enter. Good. So we want to look at 24. Okay. So we have y equals 3. Y equals x and x equals 0. So they say find the area and a graph and so on and so forth. Good. Okay. So all these are, in my opinion, not too difficult to graph. So y equals 3. This is it. Y equals x. So they have to meet at 3, 3. Y equals x, because when x is 3, y is 3. And x equals 0 is this line. So do these 3 enclose any particular area? Yes or no? Yes? What do you think? Yes.
Yes.
So green, black, and purple. So this is the area in question. I don't even need calculus to determine this. It's base times height divided by 2, the area of a triangle. But let's use calculus. So this area is, can anyone give us an idea how to write it?
It's integral from 0 to 3,
Exactly. From 0 to 3,
and then it's going to be 3 minus x dx.
above minus below. Very good. And it's the same function all the way. Same above and same below. So it is indeed 3 minus x dx. Perfect. Awesome. So then I have Can anyone give us the antiderivative?
Would it be 3x minus x squared over 2?
Excellent. Luckily, it's a polynomial, so when I plug in 0, I don't need 2 because it's 0. 3 times 3, 9 minus 9 over 2. 18 minus 9, 9 over 2. Let's see what I get with geometry. Base is 3. Height is 3. Base times height divided by 2. Any questions on this problem? Any questions? Is this better now?
Yes, thank you.
Perfect. Anything? Yes. Good. So we move on. Any questions you want to work on from 4.5 or anything else? Someone said there was something confusing, so let's go back. Which page you want me to go back?
I think it was page 434, and like, could we just go over some of those like homework problems?
Any problem? Yes. You choose.
Can we start with number 6?
Yes. So let's start with number 6. Number 6, and this is on page 434. Number 6, we have 3t to the 4th plus 2, t to the 3rd dt. Perfect. Okay. So I'm looking at the function. Oh, did I copy everything correctly? Yes, I did. There was no power on the parentheses. That's fine. So for this particular situation, you don't even need to use any substitution. Why? Because you distribute 3t to the 7th plus 2t to the 3rd, and you're done. Assuming we want to use a substitution, and just look at the function. So this is the integral from the function dt. So look at this function and say, I think I am going to use, let's say, u, or let u be, what do you think? But again, I repeat,
4 plus 2.
yes, 3t to the 4th plus 2. But you can distribute for this. If I have here 10, I will not distribute, but I can't. I have to raise this to the 10th power and then distribute. But there is no power there, right? So you could have said, like, okay, 3t to the 7th plus 2t to the 3rd and take it from there. But let's practice substitution. So this is a perfect situation as long as we have du in the problem. If we don't have du in the problem, that is not the correct substitution. What I may have or not have a number, a factor. The factor I can make up, but the rest may or may not. So what is the du for this function? This is this function. I want to find the du.
Well, t dt. Or
12.
12u dt.
So say it again. 12.
Well, t dt.
12.
Third.
Yes. dt. So I need t to the 3rd. I have it. I need dt. I have it. But I don't have the 12. Very easy to make up a 12 because it's a factor. So, right, so I multiply by 12 and divide by 12. It doesn't matter if I put it inside or if I put it outside. So now I have these 3 pieces. These 3, this and this and this are du. But now what do I replace this piece by? And then I can continue. 1 over 12 stays in front. This, and this are du. But what do I replace this by?
U.
Is it the
Say it again. It's okay if you're wrong. We're trying to establish the steps.
This is our U.
Exactly. This piece is the u. So then the answer will be 1 over 12 u squared over 2 plus a constant c. And as we just discussed again, if it's an indefinite, I have to go back. If it's a definite, I don't have to go back because the answer is a number. So I have 1 over 24. U is this. I have to square it and plus c. So 3t to the 4th plus 2. Any questions?
How did you get 1 over 12?
How did we get the 1 over 12 in front?
Yes.
Okay. So another way of looking at this problem is so we denoted by u 3t to the 4th plus 2. We determined that du was 12t to the 3rd dt. Is that correct so far?
Yeah, I got that part.
Good. So stay with me for a second. This piece has to be solved from here. So I have to divide both sides by 12. So t to the 3rd dt is du over 12. So this has to be replaced by du over 12. And this has to be replaced by u. That's where the 12 is coming from. So then from here, I have the integral from u du over 12. U du over 12. Do you see it now? Tariq, are you okay? Is this okay?
I don't know, I'm still confused.
But every piece has to be replaced. How do I replace t to the 3rd? What do I replace it by? I have to divide both sides by 12.
Okay.
So this piece
So you got,
is du over 12.
okay, I got that.
So this is du over 12. This is u.
So you're just replacing it with,
I have to solve for it in order to put it in here. I cannot just say it's du because it's not du. It's du divided by 12.
okay, so you just replace it with,
And you have 112 in front, and this is u du. I think that this is sometimes required
okay, I see.
if
Now
it's
I see.
more difficult. But I recommend, it's up to you. You can use this method. It's perfect. But when it's just a 12 or a constant or 5 or 6 or 12, 1500, just multiply and divide. This is 1. When I multiply by 12 and divide by 12, I get 1. You can say, I don't like this method. Fine. Then use this method. You cannot replace this by du because it's not du. This is du over 12.
Okay. I think I got it now.
But
I
it's
see how-
easier for a constant. If it's more sophisticated, which will not be in this class, if it's more sophisticated, yeah, then you have to solve. But if it's just a factor, I think this is more convenient, but if you don't like it, it's fine too. You have to solve then. Better?
It's better.
Okay,
Thank
perfect.
you.
It's up to you. You can use either one. I like the shortcut, but it doesn't matter. Okay, so this was number 6. Anything else you would like? Do we need to go back to anything else?
Can we do number 80?
You said which one?
80?
80?
Mm-hmm.
Very good. Good. So we have the divorce rate in Texas is approximated by, so this is 80 and this page is 435. And we have D of T equals 33.3 e to negative 0.5t. Number of divorces, so you know that I need the measurement unit. So several of you forget or keep forgetting the measurement unit on homework. Please, please, please. So this is number per 1,000 people per year. So T equals 0 represents 2010 and is in years. Perfect. Find the total number of divorces per 1,000 people from 2010 to 2015. So the total, right, this is part A, from 2010 to 2015. How do I determine the total number of divorces? So this is in number of divorces per people. So this is a derivative because it's a rate of change. It has two measurement units. Number per people, number of divorces per people, per 1,000 people. So I'm given a derivative and I'm asked to find the total number of divorces. How do I start? What is the idea here?